Hi, I'm Owen, and today we're going to talk about pulleys and work. Let's start by visualizing a situation in which pulleys might come in handy. Imagine you've just built a treehouse, and you plan to use it as a quiet place to study physics. Unfortunately, your book is very heavy, and you can't remember the last time you went to the gym. First, you try lifting it. Next, you try kicking it. You even try using the tree to provide a force of friction. At this point, your self-esteem has reached an all-time low. But you do remember your physics teacher talking about using pulleys to lift heavy objects. So you borrow a ladder from your neighbor, attach a pulley to the tree, and run a rope through it tied to your physics book. But try as you might, you still can't lift it off the ground. Suddenly, you have an idea. You climb a ladder, attach the rope to the tree, then climb down and run the rope through a pulley attached to your physics book. You then run that same rope through the pulley attached to the tree. This time, as you pull down on the rope, the book rises into the tree. The pulley is one of the 6 simple machines in physics. Using a pulley can make it easier to lift a heavy object. But why did having just one pulley not do anything? Why did adding a second pulley help? And how much did it help? In the first attempt, you used one fixed pulley. You exerted a downwards force F on the rope, which in turn exerted an upwards force of tension on the load. Now let's connect this to work. Work is equal to force times distance. Imagine that the force, F, had been sufficient to lift the book the distance, d, into the tree. In this setup, work equals F times d. In the second attempt, there were 2 lengths of rope supporting the load. One was attached to the tree, and the other ran through the fixed pulley. In this case, each length of rope only had to supply half of the tension required to lift the load. So on your end, you only had to supply half of the force. But you didn't supply half the force. You still supplied the same amount of force that you did before. So for an instant, you created more tension in the rope, and you were able to lift the load off the ground. Now let's calculate work. With this system, lifting the book took half as much force as before, but you had to pull this length and this length through the pulleys. So the work was 1/2 F times 2D, which equals F times D, just like in the first setup. In general, with more pulleys, less force is necessary, but a longer rope is required. Work stays the same.